This is for GCO8, triangle congruence with rigid motions. Last time we talked a little bit about what rigid motions were. And they are the things that it doesn't change the shape or size. It keeps it congruent. Now you might be thinking to yourself, now wait a minute, that sounds very familiar. And if that does sound very familiar, that is very similar to GCO7. And so basically it's without the whole thing of the CPCTC. Who remembers, raise your hand if you remember at least seeing the letters CPCTC. Okay, keep your hand up if you remember what CPCTC stands for. Mason, Madden, what does it stand for?
Corresponding parts of congruent triangles are congruent.
Nice, okay, good. So it's basically that without the rigid motion things. And so it's specifically with these things. You guys remember what ASA stands for?
Angle, side, angle.
Angle, side, angle, good. And then with, what is this? Side angle, side, and with side, side, side. So we're going to draw little baby pictures of what these things look like. So let's start with angle, side, angle. So start out with drawing two triangles that, to the best of your ability, look congruent. But the cool thing is because of the nice symbols that we can use, it doesn't really matter if they're super accurate. So the angle, side, angle means that we'd have one angle which we can label with one arc. So this angle and that angle are the same. And then the sides, we can do just one tick mark and one tick mark. So angle, side, and now what are we missing? Another angle. So then we do double lines here showing that that's a different angle than that one is congruent to that angle. So that's what it would look like. Angle, side, angle. And then we have side, angle, side. So again, draw some triangles. However you want to draw them is fine with me. If you want to be like a wild person, you can draw them in different positions. What? What? That is crazy. Okay, so then we might have that this side and this side are the same. Then this angle and that angle are the same. And this side and that side are the same. The nice thing with these,
could it be any angle?
It could technically be any angle. You won't have to draw them. We're just drawing pictures of how that would look. And so the reason why I did them turned like this so that you can see that they don't have to be in the exact same like position. They can be in any position. And then the last one is side, side, side. So, and my pictures are horrible. Side, side, side. But the cool thing is even if your pictures are bad, you can use these symbols like this one's the same as this one's the same as this one, and this one is the same as that one. Whoops. Like that. Side, side, side. Okay, how this one looks in ALEKS, how this topic looks in ALEKS is it will give you some triangle. It'll give you a triangle like maybe one that looks like this. And it will tell you, it'll do pictures like this, like that. And, oh, you can't see it, huh? Weird, picky people. Okay, so you have a triangle like this, and then you have just the start of a triangle. So you'll have something that looks like this, and maybe the same angle, but then it'll have like something that's just short and little like that. And it says, the directions say that you can adjust it, so then you would just grab onto this point and you can move it down or out or over to make it, to see if it is the same. So, and it says that this angle is the same. Is there such a thing as this drawing? Like is there a thing as side, side angle?
Yeah.
On the three that we just talked about, is there side, side angle? There's side, angle, side, but the angle would have to be in between those two sides. So according to these pictures, are these the same? Can they be congruent? So you would just say they're not congruent, and then you're done. Does that make sense?
Yes.
Okay. Or they might give you a picture that's basically just missing one of these parts, and then a side that's weird, and then you can move the side to try to make them, and maybe two sides that are weird, and then you can move them and see if it can make it fit one of these three theorems.
So for
GCO for 8, we're only gonna be using angles, side angles.
Yep, you're only going to be using these three for GCO8. And that's it.